Solving by taking the square roots. Solve by taking the square root. We're going to first start out with some basic examples. Our first one, we have x squared equals 25. So we must undo x squared by square rooting. And we have square root both sides, and we get x equals plus minus 5. Another way you could say it is x equals 5 and x equals negative 5. The plus and minus symbol is just a shorter way of writing your answer. Number 2, we're going to square root both sides. Now, 32 is not a perfect square, so we have to break it down. What two numbers multiply to give you 32? 8 and 4. 4 breaks down into 2 and 2. 8, 4 and 2, 4, 2 and 2. So we're circling 2 of those. So it should be 4 radical 2, but plus and minus for number 2. Number 3, we have x squared equals negative 4. So when we square root that, remember our negatives, our answer will be x equals plus minus 4i. Same thing with number 4, square root. Now again, we have a negative under the radical, so we're going to have I in our answer. But before that, we have to break down 24. 24 breaks down into 6 and 4, 2 and 2, 3 and 2. So we're going to have 2i radical 6 plus and minus. Do not forget your plus and minus signs. Our next problems we'll have here is we're going to have a little bit of a multi-step problem. So our first one, we have x squared minus 7 equals 9. To get x squared by itself, we must add 7 to both sides to cancel that out. Then we're left with x squared equals 16. Now we'll do like we did in the last slide and square root both sides, and x equals plus minus 4. Number 2, we're going to subtract 13 from both sides. And then we'll get x squared equals negative 8. So now we have a negative under the radical, so our imaginary number, we'll have our I to represent that. But we got to break down 8, 4 and 2, 2 and 2. So it's going to be plus and minus 2i radical 2. Number 3 is a little different than 1 and 2, but it's still a one-step equation solving by square roots. Well, the first thing we're going to do is undo our 2 by dividing by 2 on both sides, since we were multiplying 2 times x squared, and x squared equals 7. Well, now we're not done because we've got to take the square root on both sides. Well, 7 is a prime number, so it can't break down anymore, so we leave it with our radical over our 7, plus or minus radical 7. Number 4, we're going to divide by negative 3, just like on number 3. Cancel negative 3's out. X squared equals negative 16. Square root both sides. Again, we have a negative under the radical, so we're going to have an imaginary number. So we have plus minus 4i. The next problems, we're still solving by square root, but now we've made it into a two-step equation. Okay, the first step we'll have to do is subtract 5 to both sides. We'll get 5x squared equals 405. Then we will divide by 5 both sides, and then we'll get x squared equal 81. We're not done because we have not taken the square root. Square root, x equals plus and minus 9. 81 is a perfect square. Number 2, we're going to add 4 to both sides. 6x squared equals 378. Divide by 6. X squared equals 63. Now we'll have to square root, and break down 63. 63 breaks down into 9 and 7. 9 breaks down to 3 and 3. So it's going to be x equals plus and minus 3 radical 7. When solving by taking the square root, there are many examples I can give. We went through a series of problems where we had a one-step equation to two-step equations to three-step equations. Now we're getting into a little bit more of the multi-step equations. Our first step here is undoing the squared. Well, you see we have x plus 3 in parentheses to the second power equals 1. Well, to undo anything to the second power, we must square root the whole thing. If you're going to square root one side, you must do it to the other side. So square rooting x plus 3 squared, you are left with x plus 3. And when you square root 1, you're left with 1. Now the difference here is we have to still have two answers. So what I have to do now is take x plus 3 and set it equal to positive 1 and set x plus 3 equal to negative 1. Then I solve it like a normal equation. So I have to subtract 3 to both sides. And so one of my x values is negative 2. Then I do the same thing to the other side. And my other x value is negative 4. So my answer to number 1 is negative 2 and negative 4. On number 2, we're going to do the same thing, except before we take the square root of x plus 3 squared, we must subtract 7. I want to move everything to the other side before we take the square root. So we're left with x plus 3 squared equals negative 9. I'm going to divide this up right here. Then I'm going to square root the whole x plus 3 squared and square root negative 9. So I'm left with x plus 3 equals, I have a negative in the radical, so I'm left with 3i. Okay, now to save a little bit of space, I'm going to come down here. X plus 3 equals to negative 3i. We must do it to the positive value on the right-hand side of the equation and to the negative value. So we're going to subtract 3, subtract 3. Now we're not actually subtracting 3 to 3i since they're not like terms, so it'll be left with negative 3 plus 3i. And then the second one we'll subtract 3 to both sides. Again, we're not actually subtracting 3 to 3i because they're not the same terms. And you're left with negative 3 minus 3i. Now, since this one the answers look very similar, we can write this as negative 3 plus or minus 3i. We can leave our answer like that since we had a positive answer and a negative answer. Our last question with solving by taking the square root is very similar like the last one. Now, when we did the very last one, we had to subtract 7 to both sides. But now, instead of subtracting a number or adding a number, we're actually going to be dividing first. So if you see this 5 right here, we need to get rid of it before we take the square root. So we're going to divide by 5 here and on the other side, because 5 is being multiplied by the x minus 10 squared, so to undo multiplication, you must divide. So the 5's cancel. You're left with x minus 10 squared equals 5. So just like the last ones, we're going to take the square root of the whole thing and take the square root of 5. So you're left with x minus 10 equal to positive radical 5, because 5 cannot be broken down anymore since it's a prime number, and then x minus 10 equals negative radical 5. So we need to solve for x. Again, we're going to have two answers in our answer. So we're going to add 10. Add 10. We're not actually adding 10 to the radical 5 since they're not the same. So you're left with 10 plus radical 5 for the first one. And then we're going to add 10 again to negative radical 5. Again, we're not actually adding them together. So we're left with 10 minus radical 5. So instead of leaving it as two separate answers here and here, we can write it as one answer. And that can look like this: 10 plus or minus radical 5. The plus and minus just takes care of the positive answer and the negative answer. It's just a shortcut of writing your answer. You do not have to, but it's a preference.